In our last video, we were looking at how to differentiate a simple problem like x cubed, x squared. In this video, we're going to talk about how to differentiate sums and differences. So we may be given a complex function like this one, for example. So in this video, we're going to explain how you do this. If you've not watched the first two videos on differentiation, you can just check in the playlist or go to the channel and look for the videos on differentiation so that you may be able to understand this lesson. So the equation of a curve is not as simple as y is equals to x cubed always. Sometimes it may involve more than one term, and you may be asked to differentiate expressions like y is equals to x squared plus x cubed, or another one like, for example, y is equals to 4x cubed minus 3x squared. So in order to do this, you must be able to differentiate each term independently. That is to say, each term must be differentiated one by one. If you remember well, we say that when we want to do this, for example, in this problem, y equals to 4x cubed minus x to the power 5, what we must do first, this 3 must come and multiply the 4 before the x, like we said, and then we must also subtract 1 from the 3 there, the exponent, like we said that the 1 must be subtracted from the exponent. Again, this 5 will also come and multiply the coefficient of x, in this case would be 1, and then we're going to subtract again 1 from it. This is our function 4x cubed minus x to the power 5. So this 3 will come to multiply that 4 there, or the coefficient of x. So it will be 3 multiplied by 4 and multiplied by x to the power 3, from which we'll subtract 1. Again, we're going to do the same process. The coefficient of x is 1 this side, so we're just going to leave it like that. We bring the 5 there, 5 multiplied by x to the power 5 minus 1, and this will lead us to 12 to the power x, 12 times x to the power 2 minus 5x to the power 4 here. Alright, so 12x squared minus 5x to the power 4. That's our problem. Very simple, right? Let's try another one. Find dy dx for one with 3 this time. 4x squared minus 12x cubed plus 5x to the power 4. Again, we're going to simply repeat the same process, although with different numbers here. So the first step is to find dy dx of the first term, which is 4x squared. So it will bring us to, we multiply this 2 with the coefficient of x, which is 4, and then we're going to subtract 1 from it. So this is 2 times 4x to the power 2 minus 1, leading us to 8x to the power 1. Okay, so this is our first answer. You may also choose to write it in the form 8x, but 8x to the power 1 is going to help you remember what you've done, and to show that the power of x, which was 2, has been reduced by 1. The second step, find dy dx of the second term, which is minus 12x to the power 3. Again, this 3 is going to come this side, and then you're going to subtract 1 from there. So it will be 3 multiplied by minus 12 and x to the power 3 minus 1. 3 times minus 12, this will be minus 36 x to the power 2. Okay, so like we were discussing, it will be 3 times minus 12 to the power minus 12x to the power 3 minus 1, leading you to minus 36x squared. Then the last term is 5x to the power 4. Again, this 4 will multiply the coefficient of x, and we are going to subtract 1 from that 4, leading to 4 multiplied by 5x to the power 4 minus 1, and this gives you 20x to the power 3. So the last step would be to add up all the individual derivatives. 8x to the power 1 minus 36x to the power 2 plus 20x to the power 3. So this will be your final answer. As a general note, you must observe that I wrote 8x to the power 1 instead of just 8x in my answer. So the major reason, like I already highlighted, is that it is useful when you're differentiating, and it also makes it easy to see that the power of 2 has been reduced by 1 if you are looking at the final derivative in comparison to the original function which you were given. In general, you can notice that for any function y is equals to ax to the power m plus bx to the power n, the general derivative would be, we bring this m multiplying this a to times x to the power m minus 1 plus, again, this n is going to multiply this b, and we're going to have again x to the power n minus 1. So this will be our general derivative for any function which involves more than one term. You must differentiate each term individually and then come to a final answer. Alright, I hope you've benefited from this lesson. If you have got any question whatsoever, you feel free to rewind the point which is not clear. If you still have questions, please highlight them in the comment section. Be sure to like, subscribe, and share our videos so that others may also benefit. In our next lesson, we'll look at how to differentiate a factorized form of quadratic equations. We are not given directly as x squared, but it will be in the form x minus a or x plus a bracket x plus b. So tune in for that one.